welcome back. We got another exciting presentation. This should be fun, building dynamic distributed data store with OSGi. We have Tim Ward from Paramus, and he is a principal engineer and a co-author of one of the books that was mentioned in the previous presentation, OSGi in Action, or rather Enterprise OSGi in Action, and has been actively working in OSGi for over 5 years. He is also a regular participant in the CPEG and EEG, the expert groups in OSGi Alliance, and has led the development of several specifications. He is also active in open source communities and is a committer and PMC member of Apache Aries, which provides container for enterprise OSGi applications. Tim?
Well, hello everybody. So I think the only thing that wasn't in there and that's on this slide is my Twitter handle. So if you like Twitter, then feel free to follow me. I tweet occasionally about OSGi stuff. So yes, this presentation is about OSGi distributed data stores. So what I'm going to be talking about is a bit about OSGi Remote Services, how you can deploy and manage external processes from inside an OSGi framework using something called Packager, and then how you can dynamically wire together a distributed system. So hopefully then I'll be showing you a demo which I should be doing live on EC2, and if that doesn't convince the demo gods that I should be smitten by some horrible affliction, then who knows what will. So OSGi Remote Services. OSGi bundles communicate using the service registry. So it's a kind of loosely coupled means of communicating, and it's dynamic. So you can see here we have a consumer and it's talking to a provider through a service. This is fairly standard notation. So the service is a triangle, and the point of the triangle points at the person providing the service. So you can kind of think of it as the direction that an invocation on that service would go. So here we've got a provider B that's providing the same service, and what we can see is that if you take away provider A, you can just wire to provider B and keep working. So services are good and they let you do things dynamically. Because OSGi services are loosely coupled, they really can be, there's nothing to say about where they've come from. So in the example we had, you had provider A and provider B, and the reason that you were able to switch between them is that you didn't know that the original one came from provider A, and you didn't know that the next one came from provider B. All you knew was that there was a service that matched your requirements. So it's quite a cool thing. But it also means that you can transparently remote a service because you don't know or care where it comes from. And that's really, really quite cool, because provider B in the example was in the same framework, but if it hadn't been in the same framework, would it really have mattered? So service properties are also something that are attached to services, and you can make those available remotely as well. So you can see here we've got some provider and there's some network in the way, and our service is just transparently going through that. So the consumer can then just wire to it. Obviously, if you're going to do this, make sure your service is suitable for exposing remotely. That means that it should not use types that are difficult or impossible to serialize. So normally things like primitives, wrapper types are a good idea. You probably don't want to be doing it on a service that you're going to try and call 100,000 times over the course of an operation that's supposed to take 5-10 seconds, because the network overhead will kill you. Remember that the fallacies of distributed computing apply. So exposing a remote service is not quite transparent. So you can see here we've got a provider, and he's listed that he's going to provide a service that is both a list and a collection. Fine. But it's not being remoted right now. So you have to opt in using the service exported interfaces property. And what that does is it means that you'll suddenly appear on this side, because you've said here, I export the collection interface, which means on this side, a service can appear saying, I'm available as a collection. And again, it's gone through this network wormhole, and this is where the real service is. But as far as the consumer's concerned, he's just using this service quite happily. What you also see is a service imported true. So this is useful if for some reason you do care that this is a remote service. You can find out just by querying the service properties. You don't need to start digging into the implementation of the service or anything more complicated. It is advertised that this thing is remote if you care. So there are 2 specs in the OSGi Alliance about remoting. Remote services and remote service admin. I don't know if you went to the remote services talk yesterday. They did sort of briefly cover this. And what I've been talking about is just remote services. So as I said, network wormhole, we don't really know or care how this remoting happened. We just know that it did. And RSA is kind of built on top of remote services. So RSA works with remote services, but it tells you a lot more about how the guts of it work. So you've got pluggable distribution mechanisms, you've got pluggable discovery mechanisms, and you've got notifications that allow topology manager bundles to mess around and decide actually what should be exported and what should be imported. But fundamentally, RSA is a way of providing remote services. So I'm going to talk about remote services even though there's an RSA implementation actually doing the work, because as far as we're concerned, it doesn't matter whether it's remote services or just magic. All we care about is that the service actually gets pushed through. So that was remoting. Let's talk a little bit about packaging applications with Packager. So Packager is basically a way of packaging external programs and having them as self-describing OSGi bundles. And this is quite cool because it allows you to dynamically resolve and assemble runtimes using these things. And you can semantically version them as well. So you can have a bundle that represents something like Redis or Mongo or Glassfish or Derby or pretty much anything you want, even though it's not actually going to run in this OSGi container. What we are going to do is we're going to leverage the existing lifecycle and API of the OSGi framework. And that's good because it allows you to dynamically install and uninstall in a running system, which is a nice thing you can do with OSGi bundles. It also allows you to dynamically start and stop things. So you don't always have to have this external process running when the bundle's installed. You can start and stop it independently. And it also allows you to integrate with other OSGi specs. And that's kind of a nice thing because configuration from config admin is a lot easier than trying to deal with flat files on a file system that may or may not be there, and how do you distribute them. Config admin is a much better way of dealing with it because you can have a config admin agent that's applicable to your system, and you can then just get configuration pushed into you. You can also use and provide local and remote services to get information about the system or to do other things. And you can allow existing code to be packaged without change. And that's a good thing. You don't want to have to rewrite Redis or Mongo to say this is now runnable in OSGi, because that kind of defies the point of it. The point was you wanted to run Mongo, not rewrite Mongo so you could run it. So that's what Packager is about. So what we do is we wrap the artifacts in OSGi bundles, which kind of makes sense. We're trying to deploy them based on an OSGi framework. We should probably have a bundle in there because that's what we do in OSGi. Importantly, we're going to link the artifact lifecycle to the OSGi lifecycle. And that means that when you install or resolve, then you're going to try and install this physical binary artifact. Whether that's some jars that are getting laid down on disk somewhere, or some Linux executables, or a Windows executable, or whatever this thing is, you need to put it somewhere and make sure that it's set up appropriately. You're then going to use some service registration and unregistration to control when this thing is running or stopping. And when you uninstall the bundle, then the software should get cleaned up after itself because you've uninstalled it, it should go away. And you've then got these standard OSGi services like config admin, metatype, and the log service, which are how we should be interacting with the outside world to get things like configuration sorted. So what you've got here is a little description of how you might do this. So here we've got something saying there's a managed service factory, and this is representing Mongo, and we want to configure it with a port. So this is basically just saying, shove this port into config admin using that PID, and then deploy the managed service factory, and this thing's going to wire up, and it's going to be told, yeah, you should start Mongo, and you should start it on that port. So important separation of concerns really here. We need to know what we're running and how we configure it. And we do that with something called the package type. We also need to know when we should actually start and stop and what the real config properties are. So I was talking about the port there. That's not something that we want to package in with Mongo, because you want to be able to use the same Mongo bundle across lots of different runtimes, and they're probably going to want to run it on a different port. So we've got the process guard service that's responsible for actually saying, yeah, here's the particular configuration that you should use, and it'll be configured then by the package type service with that information. And finally, you need someone who's actually going to do the physical start, stop, and monitor to check whether this thing's still alive. And that's the packager manager and the watchdog process. So this is really one bundle that can work then with lots of different package types and process guards. So a package type, what is it and what does it do? Well, it usually contains the native parts of the thing that we're going to deploy, which means that you are actually platform specific. And it's got to have them in there because it needs to install them somehow. It could download them from some URL, but it's usually a good idea to just package them inside the bundle, because then you don't need to worry about whether the particular network endpoint is up or down or whatever. It's also going to configure this program based on the supplied config, and it's going to get some scripts which it's going to give to the packager manager to say this is how you start it, this is how you stop it, when that's appropriate. And it's usually platform specific, as I say. So, here we've got something describing Mongo, and it's Mongo 2.2, but it's the Linux x86 64 version, which is not therefore going to work on, say, my Mac. Well, maybe it would, but it's certainly not going to work on the Windows VM I've got on my Mac. It's also not going to work on something that's only a 32-bit processor. So, it's important to notice these things to be able to specifically state that we require this capability, the native namespace, that we need to have that processor, so that when it comes time to deploy, you know that you shouldn't use this version of Mongo, you should use the version of Mongo that's for Linux 32-bit or some other platform on PowerPC. So, package type, how does it work? Well, installing something external can take quite a long time, so it's not really suitable to just do it inline in a bundles activator. What you should probably do is do it asynchronously. So the bundle start happens, but you're already working away, or you're going to start working away on some other thread to get the installation done. So you could also install it on demand if you wanted to. The main thing is you need to notify possible clients that you're ready when you've actually finished. And the whiteboard pattern is a great way of doing this. Who here knows what the whiteboard pattern is? Okay, so a few of you, but not only probably about half. So the whiteboard pattern is a great OSGi pattern, which basically says, rather than having a load of listeners that you should register and have a standard kind of observer-listener pattern, getting it all wired together, what you should do is you should register a service, and then that service can be called when someone needs to call it. So it's kind of the opposite way round to the normal way the pattern works. So what we're going to do is register a package type service to say that we're done. And that's rather than calling a load of people to say we're done, we just put the service there. So service properties then advertise what this is, and if you unregister it, it means that you're uninstalling or have uninstalled and you're no longer available. So Process Guard is doing something a bit different. Process Guard is gathering config properties for our process. It is, again, using its existence to know when you should start and stop this process. And it also gets some state change events describing what's happening with this external process. And it then can also advertise that this thing is running. And it's usually platform independent. So where the binaries actually you care about what the underlying platform is, with the process guard you tend not to, because actually configuration is often platform independent. I don't need to tell Mongo to do anything different if it's running on PowerPC or x86. Not normally anyway. So most, as I was saying, configuration is often platform independent, but is this the same service? The same slide? No, just nearly. When a process should be started, you need to register the service in the service registry. And it's another example of using the whiteboard pattern to advertise yourself rather than calling a load of callbacks. So you should use the same service properties as the package type, and that's important because you need to match up the process guard with the package type, because one and the other, they work together, so you need to be able to link them, and it's the service properties that you use to do that. It's often implemented as a managed service or a managed service factory, and that's just because it allows you to automatically inject config. So you have config admin, push some config in, and the service appears. And what's cool is if you delete the config, then the service goes away. So it gives you this automatic lifecycle management where you can just use the configuration to determine whether this thing should exist or not by publishing a dictionary in config admin. Now, we'll talk about the third part, which was the packager manager. So, packager manager is going to listen for matching package types and process guard surfaces. And this is just noticing that one package type might have a lot of different process guards. And that's interesting, but what it means is that for every pair of these, so your package type and process guard, you're going to start an instance of the process. So one package type may end up creating dozens of scripts to say, start this process with this config, or with this config. So it's important to know that that can happen. You may be running multiple instances of these things. And you configure this script and get it ready to run using the properties that came from the process guard. And you've got a watchdog that monitors the process, that's then having started it, and it's going to use the scripts, again, generated by the package type, and it's going to send notifications to the process guard to say what state we're currently in. And then if either service goes away, then we need to shut the whole thing down. So that's been quite a lot of text, and I think what I should probably try and do is explain it with a nice pretty picture. So you can see we've got the three agents here, and what's going to happen is when the package type and the process guard register services, they're going to be picked up by the packager manager. So the packager manager is then going to say, I've got this pair of matching services, so it's time to get the configuration from the process guard and give it to the package type. And the package type is going to do some sort of whirring around and processing and take this configuration, and then it's going to say, okay, I'm done, so I'm going to return control to you, and I've got some scripts. And what you need to do is use those scripts to start up the external process. So that's essentially the entire flow that I was describing in lots of lines of text, but it's pretty simple when you see this nice little picture. And then what's going to happen is we're going to query this state of this thing, and then we're going to tell the process guard that it's in some state or other. And that monitoring will continue, we'll keep pinging it, and you'll know that this thing is still running or not. And then finally, if you remove one of them, then this thing gets stopped, and it gets stopped immediately. Either of those services goes away, it's time to finish. So what happens if we wire these things together? So we've got packager and we've got remote services. Can we do something interesting with that? And the answer is yes. So what you can do is you can tell lots of bits of the framework, internal or external, about what this external process is and the fact that it started. And it's, again, another good example of the whiteboard pattern. So process guards just register an endpoint, which is a marker interface, and it says, here's a URI that represents some way of accessing my external process. So for something like a database, it might be a JDBC URI. That also applies to something like Redis or Mongo or other data stores. But for a Java EE application that you've just deployed in Glassfish, it might be a URI for accessing the root of the application. Some way of maybe accessing a REST service that it's providing that you can then query and find out more about how you use the REST service. So a URI is quite generally useful, and it's just this service property that people can look at and use. And because it's a service, we can make it remotely available, which is kind of nice. And suddenly, you've started this process, but you can discover it in every single framework in your connected set. So you can use this to build a dynamically built configuration. Process guard service is still very simple. You have some static properties, and you get those injected by config admin, so just like we did before. But you can also then wait and listen for endpoints. So you can say, you've given me static configuration, and that's good, but the config's not done yet. I need to find some other information that I don't have. So you wait and you listen, and you can trigger managed service factory even with this part of the configuration. But you listen for the endpoint, and once the endpoint has arrived, you can complete your configuration, and then you register the process guard. So what you've done is you've delayed the startup of your external process until all the things it depended on were available. So effectively what we're doing is we're using the OSGi dependency and resolution model, where you would not be able to resolve and start your bundle until all of its dependencies were available. And we're doing exactly the same thing with the configuration of our external process. So you can then build this dynamic configuration by replicating out over multiple nodes, and you can build this big system where everything is is configured automatically without you actually having to say, oh yeah, it's running on this host and this port, because that's being given to you by the URI on the endpoint. So this works with Java EE servers, works with messaging infrastructure, and NoSQL stores. And because OSGi services are dynamic, we can actually even track this endpoint and say, okay, they've changed the URI, which means this service has moved, which means I'm going to need to reconfigure my system. Now that might mean that I can just change some configuration properties and not restart my process. It might mean that I need to take away my process guard completely and say, stop, bring up a new process guard and say, okay, here you go, here's the new configuration. And you can rewire your entire system based on node failures. You've built something that's dynamic and resilient just by putting together the fact that you've got some configuration that you've advertised via remote services. So let's have a look at who here knows what Redis is. Okay, again, about half of you. So we'll talk a little bit about what Redis is. So Redis is an open source key value store, basically. And you can, if you want to look at the project, it's there. It supports queries based on key data or value data, so you can sort of say, find me the value associated with this key, or what keys have values that are in this set that I'm giving you, or all kinds of comparisons. We're just going to be using it fairly simply. But values can actually be quite rich objects, like hashes or sets or lists or sorted data. So Redis is quite powerful, and you can do a lot with it. It also supports replication between nodes, so you can have slave nodes which are read-only but replicate the data that's present in the master, which you're allowed to write to. And wouldn't it be nice to have something where you could just automatically replicate out into lots of slaves without having to individually configure every node? And that's what I'm going to try and do. So I have to apologize if this doesn't work, because I'm on a 3G dongle trying to talk to Amazon Web Services. But let's give it a go. So you can see here, this is the front of my application. And you can see at the moment there's no data to display. And it's saying, is everything deployed properly? And if we go and look at my setup here, you can see I've deployed the client, but currently the master and the slave aren't available because they aren't deployed. So this is kind of what you would expect to see, which is I can't talk to Redis at all, there's probably a problem. So if we go in and we say, okay, let's start the master. So this is, I'm just using a product called the Service Fabric because it's an easy way of controlling stuff that's on EC2 without hacking around on the command line, and it'll automatically push stuff out to my servers. So that's the only reason I'm using this. The packager will run in any OSGi framework. So if I deploy, you can see that that's deployed, and if we look here, you can see that's gone green because we've deployed the master, and here we are. So you can see that the data store is healthy, and we're getting stuff from that internal Amazon IP on port 6379. So that's the master, and you can see this stuff is dynamically changing, and we've got, essentially we're polling and seeing current stock prices, which are entirely made up, so don't start making any investment decisions. And everything's good, but we're doing it all from this one port, and if the master failed, that would be a bad thing. So what I'm going to do now is, you saw I had a slave, so if we deploy the slave, and you can see here, this thing is, so it is deployed. That's red at the moment, it's gone green, which means that deployment's successful, and now we should see, hopefully, and this is the bit that I'm always worried about, it starts load balancing across the two. So it's random load balancing rather than round robin, because you never know when stuff's going to disappear or not. But you can see it's swapping between the two URLs, which are using different ports and actually different IP addresses. And that's all well and good. So the client didn't know anything about what just happened. All it saw were some services advertised saying, there's a Redis here you can talk to. The slave didn't know where the master was going to be. It didn't know what host it was going to be on, and it didn't know what port it was going to be on. It just sat there waiting for a Redis master that was in the same group as it was. So this is, quite cool. But what's also quite cool is the fact that we can then say, okay, well, the whole point of the slave is to replicate the data in case the master fails. So what happens if we simulate a master failure by just killing it? So that's been undeployed. This should go grey. And you can see now the Redis store is currently read-only because we've only got access to a slave. And you can see we're still polling data, but it's not going to change because there's no way to write to the Redis store at the moment. And then, because we're using config admin to do this sort of thing, you can use any config admin agent to just say, okay, I've got some configuration for this part, and I'm going to say it can become master true. And basically what this is going to say to the Redis is that we can happily accept the fact that we may or may not be the only one there, but if there isn't a master, then this slave can take over. Sorry, I just need to move this back over so I can find the apply button, which is off down here. So that will have applied that config. And if we go back here, you can see the data store is healthy again. And we're still using the slave URL, but the values are updating because we can write to this thing now. So that's kind of cool. What we've done is we've just done, and normally you wouldn't be doing it manually by editing config. You just leave the value there as true, so if the master dies, this will automatically take over. But what we've done is a seamless failover of our Redis data. But cleverly, the master actually can check, and if there's already a master available, it will join as a slave. So if we deploy the master again, you can see red, because we're waiting for him to find a node that he can be deployed on, gone green, and you should see that we start, so that's the master. The data hasn't actually changed from where it was, and we should continue to load balance. There we go. So what we've done is we've done a failover where the master went down, a slave took over, the master's come back up, joined as a slave, so he's replicated all the data back, and finally we can complete the loop by killing that guy. And suddenly we're still using the original master. We've had, aside from the period where we were read-only, no service interruption, no data loss, and we're still running exactly as we were to start with. And that's all been done using the power of OSGi Remote Services, which I think is rather cool. So, time to go back and just to do a quick wrap-up, which is to say thank you all for coming, because I appreciate you have a lot of choice as what to see at a conference that's like EclipseCon. There's a lot of stuff going on, so thank you for coming and hearing me talk. If you've got more questions about OSGi or Packager or want to buy my book, you should do that, and you should ask me questions now, because I think I've got about 5 minutes left.
Very cool.
How would you implement like a site-specific, so your master, you want to always prefer your master rather than your slave?
So for that, you could have that in the client, because the fact that it's a master or a slave is advertised on the endpoint. The endpoint doesn't just contain this URI. It's a whole set of properties that are then specific to the type of the endpoint. So these ones will say, I'm a slave, I'm a master, but I used to be a slave, that sort of thing. So you can pick stuff based on that. Certainly you want to be able to tell who the master is, because if you want to do any writes at all, you have to talk to the master, because that's the way Redis works. If you wanted to do it sharded as well, you could say what range of hashes this Redis is the one you should write to, or what range of hashes you can read from on the slaves. So you can use this to build not only a kind of dynamic distributed, but also a clustered sharded Redis if you want to. There's a little bit more effort and more than I wanted to do for the demo, but it's not difficult. Yeah?
Actually, I would need the 2-hour version of this talk. But
Yep.
Just a short question is, what do I need to set up the package? Is it just a Java runtime plus an OSGi runtime?
Yep, it's an OSGi bundle. Actually, it's a couple of OSGi bundles, but so you have the packager manager itself. You install into your framework, and you then need to have the thing that you want to run as an external process packaged as a package type. Yeah. So I've got a Redis package type. In fact, I've got a Redis package type and 2 different process guards, one of which knows how to configure Redis to be a master, and one of them knows how to configure Redis to be a slave.
On the packager side, do you have any native dependencies because you're starting processes and things like that, or depending on Java?
So the current implementation works with anything that has a Unix shell, or also not as well, but it does work with a Windows shell. So the packager manager needs to be able to cope with launching stuff from the command line, and also the package type needs to be able to produce suitable scripts. So package types are platform specific not only because of the binaries, but also because of the types of scripts that they produce. Does that make sense?
Yeah, it makes sense. I'm just wondering what kind of platform should you be able to run this thing?
Theoretically, anything. I mean, as long as you can launch an external process, anything. So there's another question over here.
Yeah, I just wondered what kind of transport did you use for, in this case, for Amazon?
So for Amazon, Redis, I was using the Redis client, and it's an RMI connection between the peers for the remote services stuff. Yeah, it's not complicated. It doesn't have to be with this. That's the really cool thing. So, any more questions? Anyone want to congratulate me for doing a live demo on EC2 that actually works?
Thank you, and you finished 30 seconds before this thing was supposed to go off.
Well, thank you everybody. You've been brilliant.